Welcome back. The topic for the day is
So what we have just seen is that correlation is the relationship between two variables, namely the x variable and the y variable. Now this x variable is known as the independent variable and the y variable is known as the dependent variable. That is, y is dependent on changes in x. That is, when x changes, y will also change in response to it. Now, in this particular case, what have you seen? When the selling price increases, the sales will drop. Let's take a very practical example. Now, suppose you are making and selling pudding. When you increase the selling price of the pudding, naturally, the number of people who buy your product will reduce. So let's see how the graph will appear. Now, on the x-axis, you have the selling price in rupees. And on the y-axis, you have the sales. Now, suppose for each pudding, you are charging 30 rupees. If you charge 30 rupees, then the number of people who buy your product or your sales is, say, 4 people. Okay, 4 people in your neighborhood are buying your pudding. Now, say you increase the selling price from 30 to 40 rupees. So, naturally, the number of people who buy your pudding will reduce. Say the number of people drops from 4 to 3. So when the selling price is 40, the number of people is just 3 people. Now, again, you are increasing the selling price. You are increasing from 40 to 50. So again, the number of people will reduce. So say the number of people who are buying at selling price 50 is 2. And further, when you again increase the selling price, say the number of people who are buying your pudding is just 1. So which means that an increase in the x variable. What was the x variable? The selling price. It results in a reduction in the y variable. What was y? It was the sales. So this relationship, that is when x increases, y reduces, it is known as negative correlation. Whenever the graph appears like this, that is a downward sloping curve, then we should immediately understand that it is a negative correlation. That is, for any increase in the x variable. See, x variable has increased from 30 to 40, 40 to 50, and 50 to 60. Then immediately the y variable, that is the sales, it is dropping. So this is the meaning of negative correlation. Now let's look into the relationship of two other variables, namely sales and cost. Now, when you take these two variables, that is the sales and the cost, then please note that sales has become the x variable, because in this particular case, sales is the independent variable and cost is the dependent variable. That is, the cost of production is dependent on the number of units sold, or it is dependent on the demand of the product. That is why cost has been depicted as the y variable. So always bear in mind, whatever is dependent on the other, that is a y variable. So in this particular case, cost is dependent on sales, and hence cost is the dependent variable or the y variable. Now let's take imaginary figures and depict in the graph. So sales is depicted on the x-axis and cost is depicted on the y-axis. Suppose the cost of making one pudding is 10 rupees. So definitely for 1 unit, the cost is 10 rupees. So 1 and 10, that's the marking that will come in the graph. Now, if you sell 2 puddings, then definitely you will incur 10 rupees into 2, because you are making 2 puddings. So 2 and 20. So the next plot will be here. And if you increase the number of puddings to say 3, that is, you're selling 3. Selling 3 means you're producing 3, right? So basically, the cost will be for 3 puddings, the cost is 30, because cost of 1 pudding is 10 rupees. And finally, for 4 puddings, the cost is 40 rupees. Why? Because 1 pudding is 10 rupees. So for 4 puddings, it is 10 into 4 or 40 rupees. Now, in this particular case, what have you noticed? when the X variable increases. What was the X variable? X variable was the sale. So when the X variable increases, the Y variable, that is a cost, that is also increasing. This is known as positive correlation. So whenever the graph appears like this is an upward sloping graph. Whenever it is an upward sloping graph, it means that the relationship is positive. That is, when X increases, Y also increases.
Now, in this particular example, what you have got is a perfect straight line. So there is a perfect positive correlation between the sales and the cost. Now, this may not be the case at all times. Now, suppose you are making 4 puddings, and at that time, you have to purchase the ingredients for making the pudding in bulk. And say the shopkeeper gives you a discount, which means that the cost reduces when you produce 4 puddings. So basically, the graph gets a curve, which means that the Y variable, that is the cost, has changed not only because of sales, but because of some other factor. What is that some other factor? That other factor in this particular example was a discount that the shopkeeper had given you. So at this point, I will tell you the definition of correlation. Correlation is concerned with establishing how strong the straight line relationship is. So it actually measures the strength of the straight line relationship. Now, in the first graph, what did you observe? Was a perfect straight line. That is, a straight line relationship is very strong. Or the cost is changing only because of sales. Now, in the second graph, what did you observe? There was a curve in the graph. What does this mean? The straight line relationship is not that strong because the cost is changing not only because of sales, but because of other factors also. In this particular case, it was the discount. So the straight line relationship is not very strong. So that is what correlation is all about. It measures the strength of the straight line relationship. Now, for the first graph where there is a perfect straight line relationship, we don't actually need to draw a graph and confirm that the straight line relationship is perfect. We can just calculate the correlation coefficient, and then we can understand that the graph formed will be a straight line or a curved line. So we will see the formula of the correlation coefficient. The formula is a bit long. Correlation coefficient R is given by n sigma xy minus sigma x into sigma y divided by square root of n into sigma x squared minus sigma x the whole squared multiplied by n sigma y squared minus sigma y the whole squared. What a difficult formula. But don't you worry, you don't need to learn this by heart because it will be given in the formula sheet for the examination. Now we will look into the values of R. The value of R ranges between +1 and -1. Now, if you get R as +1, then immediately we should understand that it is a perfect positive correlation. Perfect positive correlation is the graph that we had just seen. See this one. This is the upward sloping curve. Perfect positive correlation.
Now, for your understanding, I will calculate the correlation coefficient of this graph. So just look at this graph. When the sales was 1 unit, the cost was 10. So that's why 110 is the first plot. And when the sales was 2 units, the cost was 20. So that's why 220. And third one, when the units were 3, the cost was 30. So that's what is indicated here. And when the units were 4, the cost was 40. Now we will calculate the correlation coefficient R of this table. So as per the theory that we have learned, if we calculate R for this table, which has got a straight line relationship, there is a perfect positive correlation, we should get the answer as +1. We will see whether the answer that we get is +1. Okay, so I've just jotted down the formula of the correlation coefficient R. And now N means the number of observations. So in this particular case, we have got 4 observations. Sigma xy is column x multiplied by column y. This is indicated here because 1 into 10 is equal to 10. 2 into 20 is equal to 40, 3 into 30 is equal to 90, and so on. And sigma x, the total we have here 10, and sigma y, the total we have here is 100. And n, I said it is a number of observations, so it is 1, 2, 3, and 4. And sigma x squared, so I have calculated x squared here because 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. Likewise, I've calculated y squared also. 10 squared is 100, 20 squared is equal to 400, and so on. So we will just substitute the figures in the formula. We have for the number of observations, sigma xy is 300, sigma x is 10, sigma y is 100. 4, again, it's the number of observations. Sigma x squared is 30, sigma x the whole squared is 10 squared. N is again 4, that's the number of observations. Sigma y squared is 3000 and sigma y is 100 squared. So we get the answer as +1. See, I told you, if there is a perfect positive correlation, then the answer that we get for R is +1. So instead of drawing a graph, we can just calculate the correlation coefficient R. And if you get the answer as +1, then you can immediately understand that it's a perfect positive correlation. So that's the meaning when R is equal to +1. Now, if you get the R as 0, then it means that there is no correlation. That is, X and Y are not related. That is when X changes, Y will not change. It is not dependent on X. So that is the meaning of R is equal to 0. And when R is equal to -1, then it is a perfect negative correlation, the downward sloping curve. Remember the two variables that we had taken earlier, the selling price and the sales, then it was a downward sloping curve. That is when selling price increases. That is when the X variable increases, the Y variable reduces. That is the sales. Now, in this case, if you calculate R, then the answer will be -1. And generally, we can say that if R is greater than 0.8, then there is a strong positive correlation. Strong positive correlation means it will not be a perfect straight line, but it will be more or less a straight line. That is, Y is closely dependent on changes in X. When X goes up, Y will also go up. That is the meaning of positive correlation. Likewise, if R is less than -0.8, then we can say that there is a strong negative correlation. So this is the way in which you have to analyze for the values of R. Now we will look at the next topic, that is coefficient of determination, which is given by the formula R squared. What was R? R was a correlation coefficient. And what does it measure? It measures the strength of the straight line relationship. If it's a perfect straight line, which is upward sloping, then we get R as +1. And if it's a curved line, then basically we would get R, say, at 0.9 or 0.85, saying that it is not that perfect straight line. But just by calculating R, we just know that whether it is a straight line or whether it is a curved line. But that is not enough for us. We want to know how much of Y will change because of changes in X. This is what we want to know. For that, we have to find out the coefficient of determination. This measures the proportion of changes in Y that can be explained by changes in X when a straight line relationship has been established. So it simply means that how much is Y changing because of changes in X. This is what we want to know. So in the workings that we had done, we had got R as +1. So this was a perfect positive correlation. Now, if you calculate R squared, then we get 1 squared, which is also equal to 1. Now, this just means that 100% of the variation of Y is explained by changes in X. That is, Y is changing just because of X. So we will just write that in words. Changes in Y is 100% explained by changes in X. So that's the meaning of coefficient of determination. Now, if it was not a perfect straight line, then obviously you wouldn't get R as +1, right? Say you get the answer of R as 0.9. Plus 0.9 means that there is definitely a strong positive correlation, but it is not that perfect straight line. you recollect, I had said that when you were making 4 puddings, if you had got a discount, then the cost would dip and it would be a curve that is formed. So obviously, when you get a curved graph, you will not get R as +1. So say instead of +1, you get R as say 0.9. Plus 0.9 indicates that there is definitely a straight line relationship, but it is not perfect straight line relationship. There could be a gentle curve. It is at this point when you calculate R squared. What is R squared? 0.9 into 0.9, you get 0.81. It means that changes in Y is only 81% explained by changes in X. The balance, what is the balance? 100 minus 81 is 19. 19% changes in Y is because of something else. And in that particular illustration, we know what that something else is. It is the discount that we received. So this is how you have to understand about the meaning of coefficient of determination. So never get confused between R and R squared. R, or the correlation coefficient, explains the strength of the straight line relationship. That is whether it is a straight line or whether it is a gently curved line. But R squared is the crucial thing. That is the one that explains how much of the changes in Y is caused by changes in X. So that's it about correlation coefficient and coefficient of determination.